All right, welcome back. Week 4 of Algebra 2, and this week we are going to talk about rational expressions. Now, let's go way back to 4th grade. What does it mean to be rational? Well, if you don't remember that vocab term, anything that is said to be rational, like a rational number, a rational expression, is something that can be written as a fraction, okay? Something that can be written or expressed as a fraction. And so it's rational expressions. When you hear that topic at school, that's what your teacher will call it, by the way. She'll say, hey, today we're going to do rational expressions. Whenever you hear that terminology, it's just fancy talk for fraction stuff. And what we're going to focus on today is, instead of the graphs and stuff like that, we're going to focus on just putting them together with multiplication, division, addition, and subtraction. And I've kind of put this little notes guide in the order of difficulty because, in my opinion, multiplication and division are actually really nice. I don't want to say easy, okay, but easier than addition and subtraction. So let's kind of start with the main idea. When you are multiplying and dividing, every single one of these problems, your thought process should be factoring and canceling. Okay, that should be the goal. Factor and cancel, factor and cancel. The goal is not actually to multiply unless you absolutely have to. So you don't want to start by saying -4 times 64. You don't want to do that, okay? So you're going to try to go to each part separately, numerator, denominator, and see if anything factors. And if it does, factor it out. Now, if it's already factored or if it doesn't factor, just work on canceling terms or reducing terms. So we're going to reduce or cancel before we actually multiply. So let me give you an example of what I'm talking about. I'm looking at this, and right off the bat, I notice that there's a -4 over 8. So I'm going to reduce that to a -1 over a 2. Because I'm just going to take a 4 out of both of those. Now, I also notice that there's an r to the 4th over r to the 7th. Well, you may remember your rules of exponents and how you are able to reduce those. And the idea here is just that it would be these come apart with like addition and subtraction. So in other words, like r to the 4th goes into itself once. And if you take an r to the 4th out of an r to the 7th, it leaves behind an r to the 3rd. So it's almost like a simple subtraction problem, okay? Now over here, we've got an r over an r squared. Well, this is really like r to the 1st over r squared. So I would just reduce, r goes into itself once. And if I take an r out of that, it would just leave an r to the 1st behind. And then I look for any other reducing that I can do diagonally. So for instance, this 2 and this 64, I'm going to reduce those as well. So here's my round 2 of reducing on the diagonal. 2 goes into itself once, 2 goes into 64 32 times. And now I've reduced everything I possibly can, and then and only then am I going to multiply. So top times top, bottom times bottom. So it's a r to the 3rd times r. Now r to the 3rd times r would just be r to the 4th. That's got an invisible 1. And the rule of exponents is you add them whenever you're multiplying. Okay, so that would be my final answer. Okay, let's do this other multiplication problem below. Now, notice I put factor, then cancel. So my first step would be to factor everything I can. So like in this numerator, I notice that that is x plus 4 times x minus 4, just a difference of squares, over, now I'm going to factor this denominator. So let's think about that. What two numbers multiply to make 4, but then add together to make a -5? -4 minus 1, okay? So I've factored everything I can. Now on this side, x minus 1 cannot factor. X plus 3 cannot factor, so I'm just going to recopy those. Now we do the reducing or the canceling. So once you have terms that are identical, you can reduce. So for instance, this x minus 4 over this x minus 4, those can be canceled or reduced. And then on the diagonal, just like I did earlier, on the diagonal, something that goes top to bottom, since this entire numerator matches this, I can cancel those. And so the only thing left is an x plus 4 in the numerator and an x plus 3 in the denominator. Now, you cannot cancel anything here. It's going to be very tempting for you to scratch out the x, but you can't because this x has a plus or minus behind it, which means it's part of a bigger term now. So the only way you can cancel is if these two terms matched exactly, which they don't, and so that's your final answer. All right, cool. So division is going to be the same. I'll go a little bit faster. The only thing with division is, remember, when dividing fractions, don't ask why, flip the second and multiply. So that's a little riddle, embarrassingly enough, that I know. And that's exactly what you do. You just start by changing this to multiply, but then you just have to flip-flop or do the reciprocal. Oh, that's an x, not a z. You just do the reciprocal of the second term. So now all of that's gone and I just flipped it. All right, cool. Now we just math it out. So the same thing I did over here. So I'm noticing a y cubed over a y. So I'm going to cross out one of these, and this is now a y squared. Okay. I am noticing, okay, right here, there's a 3 on top here and a 9 in the bottom here, so I'm going to divide both of those out. On the other diagonal, there's a 5 in the bottom and a 25 up top, so I'm going to reduce those two. So 5 goes into 25 5 times. And now I'm going to reduce my x's. I'm going to be able to do a lot of x reducing. The first reducing I'm going to do is, my bad. The first reducing I'm going to do is right here. I've got an x to the first over an x to the fifth. So this one's gone, and it turns this one into a 4. And then look at this diagonal. I have an x to the first here that I can cross out, and that if I take another x out right here, it'll now be x to the third. So if you're wondering why I can just pick and choose which ones to cross out here, but I wasn't allowed to cross them out back here, it has everything to do with plus and minus. These have plus and minus. They are a binomial. They're stuck together. If there's no plus or minus, you can cancel anything independently at just however you like, okay? And that's pretty much all I see. So now I'm just going to put everything on top together. So a y squared with a 5y would be a 5y cubed. On the bottom, I see a 3x to the third. All right, cool. So hopefully if you took notes, you didn't make an entire mess of this like I did. Or if you did, you can still see what you wrote and see why that might be the answer. So let's do it with this one right here. I'm going to start with multiplying by the reciprocal. So I'm just going to reverse those, cross this out so I don't have to look at it. And now I'm going to do the factor cancel thing that we talked about a second ago. So does this factor? Yes, it does. I can take a 3 out. What about the denominator? Does that factor? I hope it does. Maybe 3 and 2? Let's see. Maybe a minus 3 and a plus 2? Yes, that works. This, now that I've flipped it, I can factor this as a difference of squares, 1 plus 1 minus. And now I cancel what I can cancel. So let's start crossing out. This is the fun part. Let's see. P minus 3, P minus 3, P plus 2, P plus 2. And the 3 and the 5 can't cancel, and then that P and that P cannot cancel because that has a minus. So that's it. We're left with a 3 times a P minus 2 on top, and in the bottom a 5P. So that would be my final answer. All right, cool. So you're going to love multiplication division. I actually recommend that you go ahead and stop this video and go try the ones on your sheet that are like it, because addition and subtraction is a very, very different process, and I don't want you getting the two confused and getting all frustrated. So if you frustrate easily, then please stop, go do those problems, and then come back to this video whenever you're ready. Right. So just remember it was minute 10, I guess. Okay. So addition and subtraction. This is not a factor cancel kind of a situation. This is kind of hard to explain. This is like normal adding and subtracting fractions where the goal is to get a common denominator. What makes it difficult is sometimes it's hard to get the least common denominator. I'll go ahead and write that. Least common denominator. A lot of teachers start calling it an LCD early on. They're like, oh, find the LCD, least common denominator. Sometimes it's easy, sometimes it's not. If the denominators already match, it's a piece of cake. I mean, all you have to do is recopy the denominator because they already match, and then just put your numerators together. Just be really careful with the sign in the middle, because if it's a minus, it will need to be distributed, okay, which we'll do that over here. But this is a plus, so just combine like terms, okay? B plus 2b is 3b. A negative 3 plus a negative 6 is a negative 9. So that would be my final answer. If you want to factor it, you can, but factoring doesn't really help you unless something cancels. But nothing, if we look at the top and the bottom, nothing's going to cancel. So that is my final answer, okay? So now subtraction. Like I said, you've already got a common denominator, which makes it awesome. But what you'll need to be careful of is, since that's a minus, you really are subtracting both of these. So it might be beneficial to kind of change some signs, you know, like if it was my paper, I would literally do this. I would say, okay, I don't like minus. I'm going to make that a plus, and I'm going to go ahead and distribute the minus sign to both of those, which means you're changing both of the signs of this numerator over here. I'm distributing that negative in kind of a quick, slick way. All right, and now it looks like this one over here. So we put a b with a minus 2b, and we put a negative r with a positive r. So those are just going to go away. Is that right? Yep, that is right. Okay, cool. So this is my answer. If anything reduces, now you can reduce it. And really those b's, I can cancel those out because they match. And so that's just going to leave a negative 1 over a 4r. And remember, it's okay to cancel because there's no plus or minus attached to those. So it's good to go. All right, cool. So now let's look at, well, what if they don't have a common denominator, but we have to make that happen? So here's the deal. When you look at these, if they have something in common, then yay, that is the beginning of your common denominator, okay? But if the other stuff doesn't match, then just like with other numbers, you have to multiply those together to make them match. Now, I need all 3 parts of this to be part of my denominator. Like, I can't leave anybody out. So my denominator will be the 2 that they have in common, but it'll also be an x plus 1 and an x plus 3. So you show that they are all multiplied together down here, but guys, I would not actually multiply them. Like, please do not FOIL and do all that. There is no need for that, okay? Leave it just like this. And the reason I wrote 2 of them is because this one goes with the first fraction. And remember, when you get a common denominator, whatever you did to the bottom, you have to do to the top. So this denominator, I just stuck an x plus 3 on the back, which means in the numerator, I need to do an x plus 3, okay? Same thing here. This is an x minus 2 right now, but what did I put on the bottom? Well, on the bottom, I multiplied x plus 1, so on the top, I have to do the same thing. So this is just the same law as other kinds of getting a common denominator. It's just more complicated because you're dealing with binomials instead of just a single term. Okay, so now what? Now, I told you to leave the bottom alone, and I stand by that, okay? Don't start canceling stuff out. There's a plus sign you have to deal with. So we're going to keep the denominator the same. And what we will do is we will go ahead and distribute the top. Okay, we're going to have to do all the FOIL and all that. So in the numerator, I'll switch colors here. This one is now going to become 4x squared plus 12x, okay? Plus, I'm bringing down that plus sign from the middle. Now I FOIL this side. X squared plus x minus 2x minus 2. So this is me foiling and just doing the middle steps in my head, okay? Now what? Now let's combine like terms up here. So sorry if you are running out of room, but you should have some room to groove down here. So this numerator now becomes a 5x squared, and then we combine like terms, so 11x minus 2, blah, blah, blah. All right, now here's where most of the time you're done. And on this one, I'll think about it a little bit, but we might be done because sometimes this will factor. Most of the times this doesn't factor. But if you look at it and you're like, ooh, I can make that work, then go for it. I'm trying to think if I did 5 and 1, that would have to be 2 and 1. So, oh man, almost works. If that had been a minus and that had been a plus, this would factor. But guess what? This will not factor. So this is your final answer. Okay? All right, cool. Hopefully that wasn't too horrible. Over here, we're going to do subtraction, but we also need to recognize that it's we got to make it a fraction in a fraction. So I'm going to stick that over 1, just good old-fashioned fraction rules. And I need a common denominator. Well, this has got a 3x plus 5, and this has a 1. So what that means is that this one needs a 3x plus 5, which means in the numerator, whatever I did to the denominator, I have to do to my numerator, okay? Minus, now I'll recopy all this. Cool. Now they have a common denominator, and I'm about to do some math. I do want to be careful here. There's a minus in the middle, so just like I did a minute ago, I'm going to turn that into a plus, and I'm going to distribute that negative right there because I don't want to jack that up later. You got to remember it goes to both terms. So now we're going to distribute up here, so that's going to be, what is that, 15x squared plus 25x minus 7 minus x all over 3x plus 5. Okay, so we've put those together now, and let's combine like terms. So 15x squared plus 24x minus 7 all over 3x plus 5. Okay, so if you can factor that, then factor it. And if not, leave it alone. Let me think for just a minute to see if I think it factors. That would have to be a 7 and a 1. I'm just playing over here. I'm just going to check. And I could do maybe 3 and 5. So that would be 5 and 3. Oh, that might work. 3 would be 21. Nope, that doesn't work. What if I did 3 here and 5 there? That would be 3 and okay, it doesn't work. Okay, so that does not factor, and so that would be your answer. All right, cool. Hopefully that makes a little bit of sense. So you're going to have a lot of problems to practice this week that are going to take a little bit of time. When I do the answer key, I'm going to go pretty quick through it. Keep that in mind. So you need to try them first. Otherwise, it's not going to make much sense watching me fly through them. Good luck, and we'll see you.